So again, what we're going to do today is we are going to go over Chapter 12, take a break, Chapter 13, take a break, and then go over the first bank account test. Now, I also have some news, and it's kind of funny, you know, because this would affect Tiffany the most, and I guess Ivy if they listen to the tapes. For some reason, I had to do a complete reset yesterday on using Chrome. My settings were all screwed up. Well, is that a big thing? It is for one reason, and that is it kicked me out of my YouTube login, and I can't remember what my login is. So you go online, because you can go to YouTube support or Gmail support. I don't know my Gmail account, and yeah, but it only shows you your first 10, and I've got about 30 Gmail accounts. So I've got a email into Gmail support, and I'm like, yeah, I don't think that they're gonna sit there and think, yeah, we got to help this guy. So if I don't hear from them by the end of the day, then I'm going to have to call their 800 number. I think it's an 866 number. The reason I'm telling you that is if you do talk to her, I'm going to put those lectures out there as soon as I can. But until I can get back on, I can't put them out there. They're all ready to go. I just can't do anything with them. All right. What's that? No, and when they set up accounts, I've actually found a couple YouTube videos on how to recover that stuff, but they even say on there, okay, now your account might have this. It doesn't. It says go to your About page, and the guy it shows all the stuff. My About page is empty. So, all right. So this is Chapter 12. Okay, some of this stuff we've already looked at. You know already how to create radio buttons. You know how to create checkboxes, etc. You know how to do that stuff. It's not what I would call even very difficult to do. You also know from what we looked at last time that you can either go into IntelliJ IDEA, right mouse click, and when you right mouse click, choose GUI form, and once the form's up, you can drag your components out there, or you can go actually to the code mode and add them that way. All right? So I don't think I have to tell you what GUI is. You know what GUI is. All right? So this is the kind of thing that you should technically be able to create. All right? Now, it may or may not mean anything to you, but if you look on the screen, I want to just mention a couple things. First of all, as far as I can tell looking at these are in panels. Does that make sense? Got a panel here, one here, one here, one here, one here, one here, etc. All right? The other thing, and this is something you probably don't know, what we're going to look at in just a minute is some of the layout managers. All right? And one of the most popular layout managers looks like this. Okay, it's called I think it's the BorderLayout, but I don't remember. We'll see it in a minute. But if you look at this, it breaks your screen up into 1, 2, 3, 4, 5 areas. All right? The area in the middle, it says C. That stands for center. North, south, east, and west. And what you can do with your GUI is you can put whatever you want in any one of these regions or zones. And you need to have a center, but you don't need anything else. So you can have this and not have a north or a south or a west or an east. You can do that. All right? Why am I telling you that? Because what you can put inside of each one of these zones is another type of layout manager. So you can create some really complex layouts by sticking one layout manager inside of another layout manager. All right? And that's when you start doing that, that's when you start, creating some very sophisticated looking apps. To me, it's not that it's harder than using Visual Studio, but it's very different than the way you do it using Visual Studio. That's all. And I've said this before, my guess is, had you learned this first and then went over to Visual Studio, you might think this is easier. All right? So again, it's just what you're used to doing. All right. It says Java programmers use the JFC for this. The two JFC classes, and I mentioned this to you before, that we're going to work with are the AWT, which is the Abstract Window Toolkit, and the Swing classes. I told you the story about all that stuff before. The AWT was created first. It tends to be very bloaty. In other words, it's a lot bigger than it has to be. And also, it tends not to look the same on different platforms. So when you create an AWT app or application, and if you create it on a Linux box, it might look totally different on a Mac, type of an idea. All right. And this is what they talk about with these pure classes. It's not that big a thing. Okay. So look consistent. Yeah, they're supposed to, but over time, these things were called heavyweight components for the same reason I mentioned to you earlier. The fact that they're bloaty. They take up more, they make your project bigger than they really have to be. So somebody came up with a wise idea, and this has been a long time because they're in Java 9 now, and this was in Java 2, that they said we're going to use Swing. Swing is more lightweight, they're easier to work with, etc. They have a consistent look and feel over different platforms, your different operating systems, etc. That's the idea. All right. Now, some of this we've looked at already. In other words, you know this back from the days of C#. You know, you go and you put a button on a form. You double click the button. It brings up the button's click event. You know that. You've done that kind of thing. You've written a lot of code like that. You also saw when we talked about this before, and I showed you the example. All right, I went through an example with you last week or whenever it was, and we went and did the same kind of thing. We put a button on the screen, then I right-clicked on the button and chose Add Event Listener. All right, once we did that, it said, what event listener do you want to add? We told it, and it brought that up for me. In other words, it started to write the code for me. But just like C#, just like virtually every other language, Java GUI programs are event-driven. So the system is sitting there waiting for something to happen. Literally, the term is that the system is sitting there listening for events. That's why these are called event listeners. So there's a certain event listener that fires when you click a button. There's a certain event listener that fires when you type text into a text box, etc. All right. So as it says, anything with Swing has got an X in it like that. So when you import javax.swing.star and you import java.awt.star, if you put in these two import statements, that gives you most everything that's available to you to create GUIs. All right. Now this is where it gets a little funky because, again, when we did this stuff in C#, this same stuff was done, but it was all done behind the scenes. All right. So as it says there, often applications need one or more windows. A window is called a container. A container can be displayed as a window is called a frame. You may remember this from last week. We had a panel on the screen, and then when I showed you how to write the code for you automatically, it created a frame. So panels by themselves have to be put inside of frames before they can run. All right. And again, why? Because that's the rule that somebody came up with. Once you put it in a frame, it has this stuff at the top if you look on the screen. It's got a minimize button, it's got a maximize button, and it's got an exit button. That's one of the things that it buys you. All right. As it says, these standard features sometimes are referred to as decorations. So there's a simple window. Now that's not going to do very much, but you have to write code to make that happen. Now, if you remember from C# a year ago when you were taking C# and we started to do GUI applications, all you had to do was select that you wanted it to be a GUI, and it drew that form for you. All right? You can't, it's not like that here. Here you have to draw it. And one thing, if you remember last week, I don't know if you remember this or not, but when we did this last week and I ran it, the results showed way up here in the upper left-hand corner, and they were real small. And that's because we didn't do this. We can set window height and window width, and that's in pixels. So if I set it to 500 by 600, it's going to be pretty darn big on your screen. All right, there's even ways that you can set it to where it comes up on the screen. So if you want it to come up in the center, etc. We didn't do any of that. We didn't do anything special. All right. So as it says, when you create a new JFrame, that's how you do it. You can call it anything you want. It's common to call it window because you're making a window, but you don't have to do that. Notice again, a JFrame is initially invisible, so you have to make it visible. You may remember that. We talked about it before. Other things that you have to do, if we did this, if we set up a couple constants for the window's height and width, then later we can tell it to set the size of the window. We can tell it to use those constants. That's typically the way it's done. It's just the way it's shown right there. This says when you click that X button, so when you're running it and you click that button, it's telling it to close. That's it. Well, that makes sense. Yeah, but it's not smart enough to close unless you put that line of code in there. All right. And we talked about the fact that when you do this, you have to set the visible to true. All right. All right. We usually use inheritance to create a new class that extends JFrame. Yeah. That might be your panel or whatever. All right. Here are some of the components that you can use. Now, there's good news about this, just so you know. This pretty much is going to be what you're going to be using in Android. Okay, you're going to be using JLabels and JText fields and JButtons, etc. Okay, and I think it's probably even easier to do it in Android land as opposed to the way we're going to do it. All right, you'll draw your own conclusions as you get more and more comfortable with it. So they show some stuff on here. Again, I don't think we have to go over this because the big thing is we don't call it a text box in Java. It's called a text field. Now, is that a big thing? No. But the big thing with when you work with a text field, just so you know this. Know how we've been working with getters and setters? Well, text fields have a set text and a get text. All right? So if I want to set this in here, if I want it when the program runs, they have that be a 0, for example. If I want that when the program runs. And let's say that that's called, I don't know, kilometers, or let's just say it's called kilo. Kilo dot, be this one, kilo dot set text, and I put in here 0. And if I do that, it'll do this. And if I say kilo.getText, it'll give me 0. All right. This is all stuff, even if you don't think so, this is all stuff you've looked at, you've used literally or very close to it in other languages. You've done this stuff before, is what I'm telling you. All right. So how do we do that? Well, notice how we do it. We're working with an object-oriented language, so all of our controls are going to be private. That should make sense to you. All right. And here's some examples. So this is going to create a brand new text field, and it says new text field 10. What that 10 is that's how wide you want the field to be. Not how many characters you can put in it, but that's how wide you want it to be. Here's creating a button. Here's creating a label. So in other words, what they're showing you is this stuff right here. The label that says enter a distance in kilometers, the text field, and the calculate button. That's how you put them in code. All right? The good news is you don't have to do that. And what I mean is when you use the GUI tools and you drag stuff out and you set the properties, that's the code that's going to be written for you. But you do have your choice. You can either use the GUI tools, which I think is much easier, and drag stuff out, etc., or you can write it as code. All right? Now you saw this content pane. Okay, it says it's a part of every JFrame object. The content pane is not visible, and it does not have a border. One bad thing about here is they don't show the picture of this. It says a panel is also a container that can hold GUI components. Well, hopefully you remember this from last week. That panel was created for us automatically. All right, that literally is the equivalent of our form that we had in C#. Now, I'm not going to read any of this stuff. You know, a panel basically is, again, it's like a big container, for lack of better words. And you put stuff into it. So you create a panel, then you add things to it. All right? Then you have to add the panel, and that adds the panel to the JFrame. All right. These action events are what we talked about before. This is the equivalent of when we worked in other languages of double-clicking on a button or whatever. That's what's happening here. All right? And it gets to be a little weird because with some of this stuff, there's two ways that you can do it. And it sort of looks like it's the same thing, yet it sort of looks different. All right? So, an event listener, as it says, is an object that responds to events, okay, like the click event that we used to have in C#. They're specific to each application. The good news is, again, you don't typically have to write them. You have to write the code that goes in them, but you don't have to write the actual event listeners themselves. Those will be written for you by the way I showed you the other day. Now, even if you haven't been listening so far, if everybody would just take a quick look up on the screen. When you write these, quite often what you have, because this is the first time you've seen this, where it says public class outer, that's what we've been doing so far. We've got a public class, that's the name of our Java file. But when you start to write these GUIs, you make inner classes. You can have only one public class in any one Java file, but you can have as many private classes in that same file as you want to. So typically what you do is you create a private class where you put all of, for lack of better words, virtually for every one of your GUI components. And again, if that doesn't make sense, you're going to start seeing it, okay, hopefully next week. All right? If not earlier than that. So all event listeners must implement an interface. The good news is you all know what an interface is. You know how to use the implements command. You all know that. All right? Nothing new there. An interface is something like a class containing one or more method headers. When you write a class that implements an interface, you're agreeing to that. So in many ways, I just want to make sure that I'm trying to pull together stuff. In many ways, an interface is like an application program interface. An interface, an API is an example of an interface. So in other words, it would be like if you came into class one day and I give you all, in fact, next week, I give you all these rules and I say, you know what, you can have, while you're in class here, all right, I mean, you can have this Android tablet number 6, and you can use it in class, but you have to agree to use it, and you have to agree to the rules that I give you. Maybe I make you sign something, I don't know. But if you do that, then you're implementing the interface that I created. Right? So when we start going through this stuff, this is what you're going to be doing. This public void action performed that you see on the screen, that's the equivalent of your button click event. All right? Again, the good news is much of this code is going to be written for you as we put stuff on the screen. Bad news is not all of it will be. All right? By default, a button knows when it's clicked to look like it's pushed in, but a button won't do anything by default until you tell it to do something. That should make sense. So it says here the JButton component generates an event, passes it to the event listener, and that event listener's object action perform method. So you've got a button here, whatever this is, let's just say that's a button. You click the button. What happens next is based on the code you put into that button's action perform method. Is what I'm telling you. That's, again, like the equivalent of putting it in the click method. All right? Now, the problem is when you work with this stuff, you can't just start using it. As it says here, that when you create an event listener, you have to do what's called register it. So if you look right here, what is this line doing? This line that you see right here in the blue, it says we're going to add a brand new action listener. All right, it's going to be for our calculate button, so we're going to call it calc button listener. So what that does is it registers. So it's letting the system know when you click the button called calc button, you want the action perform method for the calc button listener to run. Right? Java allows you, just like we've seen this before, work with colors. Now one thing, these are the 13 predefined colors. If you remember back from the days of C#, it was much easier because you had that color panel and you could sit there and set colors. Normally you don't do that in Java, you use one of these. All right, so for that reason, your programs might look a little more blah in Java than they do in other languages. Right? Now, do you all understand, if you take a look right there, black, cyan, gray, light gray, orange, red, yellow, blue, dark gray, green, magenta, pink, and white. They're all in caps. So they're all constants. All right? What's that? Well, you can do it. But what I'm saying is this is what you get out of the box. All right? But the point is, notice that before each one of those 13, it says color dot. What that means is there's a color class. And this color class holds, among other things, these 13 built-in colors. Okay. All right. The ActionEvent Object. This is where it gets a little funky because there's two ways that you can write code. The only way to show you this is going to be to show you this. But I decided to still go over this stuff first before we start writing it. All right. You can use getSource and you can use getAction command. And you say, well, what's the difference? You have to see it to understand. It does the exact same thing, but the code you write is different. All right, that's the best thing I can tell you. Bless you. All right. Java supports several layout managers. You may or may not remember, but when we looked at that example the other day, we had a grid layout. All right. I changed it from a grid layout to a flow layout, which was probably a mistake. If you leave it as a grid layout, it gets to be where it's very selfish. So if I put a button by default, it takes the entire width of the screen for that button. It puts it right there. If I put another button underneath it, it'll go underneath it, and that'll take the entire width of the screen. All right. So the default is flow layout, but not in IntelliJ IDEA. The default in IntelliJ IDEA is actually grid layout. That's why I've got it in blue up there. The border layout is what I showed you up here with the north, south, east, and west. They're going to show you examples of each one of these. All right. So you have to tell the system, I'm using this kind of border layout. It's not smart enough to know until you tell it that. All right. You use what's called literally a FlowLayout Manager. And all you're doing to use the FlowLayout Manager is something like this. You're telling it what kind of layout you want it to use. And again, you can make this look a lot different depending on the different layout manager you choose. Okay? All right. When you set it up, you can tell your components you want them to be center aligned, left aligned, right aligned, etc. Okay? There's more stuff you can do with this gap. That's how much space you put between components. By default, it'll only put like about a pixel or so in between different components. But if you want it to be wider than that so that it stands out, you can do that. This is the picture that I tried to draw up on the screen before, if you take a look. So that's a BorderLayout Manager. And again, I said this to you, I'm saying it again. The center component, or what they call the center region, it's greedy. What that means is, if I don't have a north region up here, then the center grabs every bit of it that it can. So in other words, if I don't have a north region, so if I get rid of this, it's going to look then like this. That makes sense? If I decide I'm not going to have an east region, you can see who takes more room up. All right? The center is greedy. It takes every bit that it can possibly take. All right? It has 5 regions. You have to use the center, but you don't have to use any of the other 4, but you can use all of the other 4 or any combination. All right. That's how you use them. Border layout dot, and the IntelliSense should kick in then with north, south, east, west, and center. All right. So what are they doing here? Now they're saying, oh, I want to add a button into my north area. What's that going to do? It's going to bring that north area up there, and it's going to put a button in there, depending on whether you told it to be, well, wherever it was, left aligned, right aligned, center aligned. All right, whatever you tell it to be. All right. Okay. If the user resizes the window, the sizes of the components will change as well. You'll see that when we start working with it. All right. Again, I already mentioned this to you about nesting components in a layout. So I can put a layout inside of a layout. Okay. And it's actually not as hard as it even sounds to do. This is what we talked about. This is what we looked at. I believe this is what we have for the default for IntelliJ IDEA. And most of the time, they draw it like a spreadsheet. What that means is every time you put something in it, every single one, if you imagine that your screen is like, what do they have here, 25 squares? Every square is the same size. So if I put something in this square right here, and it's not that size, if I put something in that square that's this size, then all the other squares that are in there, they're going to expand. They have to all be the same size. It's a grid where everything literally in the grid is the same size. And when they say it follows some simple rules, those are the rules I just gave you. All right? And they show us some examples. Okay? Now, when you look at this, there's radio buttons. When you create a radio button like this, JRadio button, the name equals new JRadio button. Notice if you do this, if you create one and you say true, that means it's checked by default. Not only that, when you create a radio button, I think they showed it here, yeah, you can have a radio button group. That's typically what you're going to have. So for instance, if I had something called gender, all right, I might come in and I might put it into a group, okay? So we create these, and then we create a group, and then we throw the buttons in there. Now look at that, if you would. That's literally going to create something that looks like this. Choice 1, choice 2, choice 3, all right, with the radio button. That's what it's going to be. And we're telling it by default we want this one to be selected. Okay? Once we do that, these buttons are not connected. They're not until we do this. That says to put them into the same group. All right? Then once we do that, we add them. It's like an invisible border gets put around them, so that if we change this and we click here, that one won't be selected anymore. That kind of an idea. Again, you're going to see this. Radio buttons, they generate an action event. What does that mean? That means you handle a radio button just like you handle a regular button. All right? Some of this stuff we've actually looked at things similar to this back in the day when we talked about C# is selected as a Boolean property. If it's true, the radio button has been selected. If it's false, it hasn't been. This is kind of cool. Selecting a radio button in code. You can say, for example, the name of a radio button .doClick, and it'll select it for you. All right. Checkboxes, you know what checkboxes are. Okay. You don't typically put those into a group. But checkboxes, they've got a different interface. So buttons and radio buttons both implement one interface, and checkboxes, they both implement the action listener. But checkboxes implement the item listener. Okay? You won't remember that anyway, but just at least you've heard it. As they say here, notice they're putting borders around things, very similar to panels that we've looked at in other languages to make stuff stand out. A lot of ways that you can set up borders. They show some of them here. Now, what I'm going to ask you, not right now, but next week, is in this book, and I think I've got the code, all right, they actually create this application, and now they don't show it, of course. It's called Brandi's Bagel House. It's kind of a stupid little application, but what it shows is they break up the screen where you can order bagels. Then next to it, you can tell what toppings you want on the bagels. Then next to that, if there's something else, I don't remember what it is. Then next to that is, do you want coffee type of thing. And it allows you to add a bunch of different things, and it configures your bill. Now, I was thinking we probably would write that next week as a class just so you could see what it looks like. All right? Does everybody know what a splash screen is? I don't want to assume anything. You know, has everybody tried some kind of software in your life that when it first starts, you see the logo for the place, and all of a sudden it fades out of view? All right, that's a splash screen. This Brandi's Bagel has a splash screen with it. All right, not very hard to do. Finally, and I think I've talked to you about this before. Maybe you've noticed that there have been at least times when I have both done a JOption pane and done the system.out.println. What a lot of developers do is they use their JOption pane for all input and all output. But if they have any kind of error that they want to print out, they use system.out.println. All right? Well, that's it for the first chapter, mercifully. So it's 126. Let's come back at 140, please. And when we do, we will go over chapter 13 at that time.